Hello everyone, this is Heading Tian. In this video, let's learn chapter 5.2, right triangle trigonometry. Okay, the first part is define trigonometric functions of acute triangle. Consider a right triangle. Just look at this picture. With an acute triangle theta, the longest side in the triangle is hypotenuse. This is the longest one. So that is also the opposite side of the right angle. So you see, this is the opposite of the right angle. Okay. The two legs of the triangle will be distinguished by their relative position to theta. The leg that lies on the ray of angle theta is called adjacent, and the leg that lies across the triangle from theta is called opposite. So you see, this is the opposite of theta. And there are 6 trig functions. The first one is sine theta. Sine theta equals opposite divided by hypotenuse. So that's opposite divided by hypotenuse. This one is cosecant. So cosecant theta equals hypotenuse over opposite. So this one is the reciprocal of sine theta. Some student ask me what is reciprocal. So if I have 2/3, the reciprocal of 2/3 is 3 go to the top and 2 go to the bottom. So the reciprocal of this one is 3/2. So the cosecant theta is 1 over sine theta. So just switch the position of the opposite and the hypotenuse, which is h over opposite. Cosine theta equals adjacent over hypotenuse. That's the length of the adjacent side, divided by hypotenuse, longest side. Secant theta equals hypotenuse over adjacent. This is a reciprocal of cosine theta. Tangent theta equals opposite, the length of the opposite divided by the adjacent, the length of the adjacent side. Cotangent theta equals 1 over tangent theta. That's the adjacent over opposite. Here is the conclusion. So read it by yourself. In the right triangle, for example, the ABC, this triangle, the sine theta, this is theta, that equals x over b. That's the opposite divided by hypotenuse. And we extend the AB to D, AC to E. So sine theta is also equals opposite divided by this part, the hypotenuse in this triangle. So it's y over d. What's the meaning of that? That means sine theta equals x over b in the small right triangle here, and also equal y over d in this big triangle, right triangle. So theta is fixed. So the ratio of x and b, y and d are the same. Evaluate the trigonometric functions of acute triangles. Here is the Pythagorean Theorem. In the right triangle, C is the longest side, that's the hypotenuse. A and B are 2 sides, this one and this one. And the relationship is A squared plus B squared equals c squared. We will use this very often in our following questions. If we know these sides in the right triangles, we will find all 6 trig functions of the acute triangle. For example, in this right triangle, they provide us 3 legs. So the sine is, sorry. So for example, for sine B, the angle is B. Sine B equals opposite, that's 4, over hypotenuse is root 65. And cosine B equals adjacent 7 over hypotenuse over square root of 65. And tangent B equal opposite, that's 4, divided by adjacent, which is 7. And cosecant B equals what? That's a reciprocal of sine B. So actually you don't need to memorize the cosecant. You just know that's 1 over sine B. Or you just flip it. That is square root of 65 over 4. And secant B equals reciprocal of cosine B, that's square root of 65 over 7. Cotangent B, that's the 1 over tangent B, that's 7 over 4. So if there are, they gave us 3 sides, we will find all of these 6 trig functions. Using known value of trigonometric function to determine other function values. Suppose cosine theta equals square root of 5 over 3. For the acute angle theta, evaluate tangent theta. First, we draw a right triangle and we assign this one is theta and this is 90 degree. And so cosine theta equals adjacent over, cosine theta equal adjacent over hypotenuse. This is opposite. So cosine theta equals a over h. They gave us that's square root of 5 over 3. We learned before that the ratio is the same, so we can assign that a equals square root of 5 and the hypotenuse equals 3. So by the Pythagorean theorem, that's O squared plus A squared equals H squared. So we want to find O squared equals H squared, subtract A squared. Plug in the number 3 squared minus 5 square root of 5 squared. That's 9, subtract 5, that's 4. So O squared equals 4. So O is plus or minus 2. But we know the length of the triangle can't be negative. So we can only choose 2. Right now we know all of these 3 legs. So we can find the 6 trig functions. Sorry, this is 2. So sine theta equals opposite, that is 2 over hypotenuse 3, that's 2/3. And cosine, we already know that is root 5 over 3. And tangent theta equals opposite, that's 2 over adjacent, that's square root of 5. And cosecant theta equals the reciprocal of sine theta, which is 3 over 2. and the secant theta equals 3 over square root of 5, and the cotangent theta equals square root of 5 over 2. So we find the 6 trig functions. Actually, the question only asks about tangent theta. So we have the tangent theta is like this, and then we need to rationalize this. So on the top and bottom, we need to multiply by square root of 5. Square root of 5 times square root of 5. The bottom part is 5, and 2 times square root of 5 over 5. This is the answer of tangent theta. So you can also rationalize this number. Okay, let's move on to part 3. Determine trig function values for special angles. This one, maybe we will take more times to work on, because, okay, for this one, if you feel this one you don't want to learn, you can skip, move to next part. But if you want to learn how we find the value of sine 45, cosine 45, and sine 60, evaluate the sine 30 degrees. So you stay here and listen. First, we need to draw a right triangle. In the right triangle, this one is 90 degree, and this angle is 45. And you know, the sum of these 3 angles equals 180 degrees. So 180 minus 90. So we have 90. So this one is 45. This one must be 45 degrees, because 45 plus 45 equals 90. Okay, if we see the right triangle, this angle is 45, this angle 45, they are the same. So the leg here and here are the same. We just assume this one is A, this one is A. By the Pythagorean theorem, we know that hypotenuse h squared equal a squared plus a squared. That's 2a squared. So h equals square root of 2a squared. That's equals a times square root of 2. Sometimes we say square root of 2 times a. So sine 45 equals opposite divided by hypotenuse. That's a over square root of 2, or square root of 2a. That's the 1 over square root of 2, and rationalize that times square root of 2 both sides. That's square root of 2 over 2. And cosine is the same, 45 degrees. That equals the adjacent, that is a, over square root of 2 or times a. So the same answer, square root of 2 over 2. And tangent 45 equals opposite, that's a, over over adjacent, which is a, that is 1. So we find the 3 trig functions, and another 3 are the reciprocal of these. So cosecant 45 equals the reciprocal of sine 45. That's 2 over square root of 2, that's square root of 2. And secant 45 equals 1 over cosine 45. That's square root of 2. And the cotangent 45 equals the reciprocal of tangent 45. That is 1. So we found this part. Next one, evaluate sine 60 degree, cosine 60 degree, and tangent 60 degree. Right now, we need to draw a picture that has the right triangle, has the acute angle, which is 60 degree, because this one and this one are complementary. So this one is 30 degree. Right now, actually, we have learned that if this one in the right triangle, this one angle is 30 degree, this one is 60 degree, and this shortest leg is the half of longest leg. So this, if this is A, the longest hypotenuse is 2A. By the Pythagorean theorem, we can find this leg. This leg, we use B. So A squared plus B squared equals C squared. C squared is 2A squared. And isolate the B. B squared equals 2A squared. Subtract A squared. That equals 4A squared minus A squared, which is 3A squared. So the B is A times square root of 3. Right now we know this part is square root of 3 times A. Right now we can find the sine 60 degree equals opposite, which is square root of 3A over 2A. That's the root 3 over 2. Cosine 60 degree equals adjacent, that's A, over the hypotenuse 2A, that's 1/2. And the tangent 60 degree, that's opposite square root of 3A over A, that's the square root of 3. And so the cosecant 60 degree equals 2 over square root of 3. Rationalize that, that's 2 times square root of 3 over 3. Secant 60 degree, that's equals, just flip this, that's 2. And cotangent 60 degree equals, that's equals 1 over square root of 3, that's square root of 3 over 3. Okay, evaluate the sine 30 degree, cosine 30 degree, and tangent 30 degree. Actually, we can still use this triangle because we know this is 30. So the sine 30 degree equals opposite of this this angle, which is A over 2A. The hypotenuse, that's 1/2. And cosine 30 degree, that's equals square root of 3A over 2A. That's root 3 over 2. And tangent 30 degree equals opposite, that's A over square root of 3A. That's square root of 3 over 3. So we can also find the cosecant 30 degree, that's equals 2 because the reciprocal of 1/2. And secant 30 degree equals the reciprocal of cosine 30 degree, which is 2 on the top, square root of 3 over 3. Cotangent 30 degree, that's square root of 3. Just flip this and rationalize, simplify that. Okay, let's move on. If you think, oh, it's so hard to memorize the procedures, you just memorize the value of sine 30 degree, cosine 30 degree, sine 45 degree, and sine 60 degree. So just memorize the value in this table. Okay, so the first I need to explain is that 30 degree equals pi over 6. Since 30 degree equals the one for rotation, that's 360 degree over 12. And also I can convert it to the radians. That is 2 pi. That's 1 rotation over 12. So 2 pi over 12 is pi over 6. That means 30 degrees equals pi over 6. So how about 45 degrees? So 45 degrees equals what? Let me see. 1 over 8 times 360 degree. That equals 1/8 times 2 pi. That's pi over 4. Is that right? Yes, that's right. How about 60 degree? 60 degree equals 1 rotation 360 over 6 equals 1 rotation 2 pi over 6. That's pi over 3. So memorize this when you see the degrees and radians, they are convertible. Okay, let's see so I have a special trick to help you memorize these 6 values. So when theta is 30 degree, sine 30 is 1/2. I use your left hand to help you memorize that. So imagine that this is xy plane, and the plane is divided by xy into 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in the first quadrant, assume this is the first quadrant, and assume your fingers, this one, your little finger and your thumb are x and y. Let's clean this. And this one, assume this, oh no. So assume that, so sorry. This one is 30 degree. And this one is 45, it's in the middle. So this one is 45. And this one is 60 degree. So this one is 60 degree. So it's very messy. Maybe I just draw 3 lines there, and you know that's no. Okay, we are back. Okay, this is 30 degree, and this is 45. Just put 45 here, and this is 60 degree. And you see when I see the value here, these 6 values, they all have the same bottom, which is 2, 2, 2, 2, 2, 2, 2. And only the tops are different. The tops, we can make square root of question mark over 2. All the things has the same denominator bottom. And what should I put on the top? One is sine 30. So this is 30 degree. How many fingers below this line? I just have 1. This is the 1, your finger here. So the sine 30 equals the question mark, I put 1, and the bottom is 2. Square root of 1 is 1, so it's 1/2. How about 45? Sine 45 degree. That equals how many fingers below this line? We have 2. So in the question mark part, I put 2 over 2. And how about sine 60? The 60, how many fingers below it? We have 3. This one, and this one. So in the question mark, I put 3 there. I have square root of 3 over 2. So this is a way to help you memorize the sine angles. And how about the cosine? So the cosine is the same, but we count by the opposite way. So let's clean up this. Okay, we still have 30, 40, 60. These three angles are the same, but when we say cosine 30 degrees, count how many fingers above 30. So how many fingers above 30? This is 1, 2, 3. There are 3 fingers above 30. So in the question mark part, I put 3 over 2. I still use this one. And how about cosine 45 degree? How many fingers above 45? We have 2. So square root of 2 over 2. Cosine 60 degree. That's how many fingers above 60? We have just a 1. So square root 1 over 2. That's 1 over 2. This is the way to help you memorize these 6 values. And for the tangent part, you need to memorize it by yourself. And remember, for the tangent, we have actually only 2 values to memorize. One is square root 3 over 3. One is root 3. So which tangent special value of tangent should be square root of 3? So I use my way to memorize because I know that 30 degree is small. So tangent 30 degree should be square root of 3 over 3. And tangent 60 degree, this one is bigger than 30. So, sorry, this is 3. So this one should have a big value, which is square root of 3, not the square root of 3 over 3. This is a way to help me which tangent special angle should have square root of 3 over 3, which special angle tangent has square root of 3. So this is the way I memorize these 2. And in the middle one, the tangent 45, that is 1. I only memorize these 9 values, these 9, and then it's easy for me to find the rest of that because cosecant theta equals the reciprocal of sine theta. So 1 over 2's reciprocal is 2. And 45 cosecant, that's the reciprocal of sine 45. That's square root of 2. So that is, so you will save a lot of time to memorize this table. Just memorize these 9 values, and there's no use to memorize these. Just use the reciprocal relationship to find the value. Remember, this table is very important. So here are the examples. Let me clean up this. Oh. Okay, in the first question, we have tangent 60, subtract tangent 30. We know tangent 60 is square root of 3, and tangent 30, that's square root of 3 over 3. So the value should be 2 times square root of 3 over 3. 2 times sine pi over 6 times cosine pi over 6. Sine pi over 6 is sine 30 degree. That's 1/2. And the cosine pi over 6 is square root of 3 over 2. That's equals square root of 3 over 2. Okay, let's move on. Use the fundamental identities. That's just the reciprocal and the quotient identities. Cosecant theta equals 1 over sine theta, or sine theta equals 1 over cosecant theta. So sine theta and cosecant theta are reciprocals. And secant theta equals 1 over cosine theta, or cosine theta equals 1 over secant theta. So cosine theta and secant theta are reciprocals. And cotangent theta equals 1 over tangent theta. So you read it by yourself. So tangent theta and cotangent theta are reciprocals. And tangent theta equals sine theta over cosine theta. So some student asked me why. So let me draw an right triangle. And longest side is hypotenuse. I use H to represent. And this is the theta. Opposite, we use O. Adjacent, we use A to represent. And the sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And how about sine theta over cosine theta? That's opposite over hypotenuse, adjacent over hypotenuse. So this one divide this one equals this top times the reciprocal of the bottom one. That's equals O opposite over hypotenuse times flip these, which is H over A. H canceled out. I have opposite over adjacent. Do you remember tangent theta equals opposite over adjacent? That means tangent theta equals sine theta over cosine theta. So this is why this shows you there. Cotangent theta is a reciprocal of tangent theta. So you just flip the position of these two. We got cosine theta divided by sine theta. Okay, let's move on to see the example. Sine alpha equals 5 over 8. Cosine alpha equals square root of 39 over 8. Find other trig functions. So they provide us 2 trig functions. We have to find the other 4 trig functions. So we can use this one to find the tangent theta. And the reciprocal of tangent theta is cotangent. So we have this. And cosecant alpha equals the reciprocal of sine. So this one equals 8 over 5. Secant alpha equals 1 over cosine alpha. They provide us here, and we got this. Some students don't know how to rationalize this because the square root is on the bottom part. So we need to multiply up and the bottom by square root of 39. Square root of 39 times square root of 39. So this one is 8 times square root of 39. Square root of 39 squared. Because the square root and the squared, it can be canceled. So 8 times square root of 39 over 39. Okay, let's move on to see 3 identities. These are the important identities, which is sine alpha squared plus cosine alpha squared equals 1. Tangent alpha squared plus 1 equals secant alpha squared. Cotangent alpha squared plus 1 equals cosecant alpha squared. So let's use these identities to work on some questions, some examples. First one, tangent theta equals 12 over 5. How about secant theta? Because we know that tangent theta squared plus 1 equals secant alpha squared. sorry, theta, because this question is theta. So plug in the value of tangent theta, 12/5 squared plus 1 equals secant theta. So secant theta equals square root of 12/5 squared plus 1. Okay, let's move on. Remember the complement angle of theta. So we have learned that, no, come back. We have learned if alpha plus beta, if alpha plus beta equals 90 degrees, so alpha and beta are complementary. In the right triangle, for example, this picture, we know the sum of the three angles, this one, and this one, should be 180 degrees. That means if this one is right triangle, that is 90 degrees. That means this one plus this one is 90 degrees. So if this one is theta, this one is theta, this one should be 90 degrees minus theta. Okay, remember the complement angle of theta. So these are important. Sine theta equals 90 degrees. Subtract theta, that equals A/C. So A/C, opposite divided by hypotenuse. Tangent theta equals cotangent. So tangent, cotangent, sine, cosine. So tangent theta equals cotangent 90 degrees, subtract theta equals A/B. That's the opposite over adjacent. Secant theta equals cosecant 90 degrees, subtract theta equals C/B. Okay, let's move on. This is the conclusion of cofunction identities. Sine and cosine are cofunction. Why? Because sine theta equals cosine 90 degrees, subtract theta. So sine and cosine are cofunction. And if the function satisfied by this, so sine, cosine are cofunctions, and tangent, cotangent are cofunctions, secant and cosecant, they are cofunctions. And they satisfy the relationship of this, just the relationship we learned about. And remember that 90 degree, that also can be converted to the radians form, which is not pi/2. So when you see sine theta, you need to recognize that equals cosine pi/2, subtract theta. Okay, let's move on to next part. Pause the video and read the table. The example, cotangent 15 degree equals 2 plus square root 3. Find the cofunction of cotangent 15. We know that the cotangent cofunction is tangent, and that equals 90 degrees minus 15 degrees. That is tangent 75 degrees. And they also have the same value as 2 plus square root 3. Next example, cosine pi/6 equals square root 3. Find the cofunction of cosine. Cosine cofunction is sine. So this is sine 90 degrees. So that's also equals pi/2. Subtract pi/6. That's sine pi/3. equals square root of 3/2. Okay, let's move on to the next part. Approximate the trigonometric functions on a calculator. Because my iPad doesn't have the calculator, so I will use my laptop to record the video, and that video will be separate with this one. So if you want to know how to use calculator, the TI-84 to put the data in, watch another video. Okay, let's move on to this example. Use the trigonometric function in applications. Here I need to claim two definitions. One is angle of elevation. Angle of elevation is an angle measured upward from a horizon line reference. So if you are here, your eyes are here, you are looking, and here is a horizon line, and measure upward from the horizon line. That is the angle here. This is the angle of elevation. And another definition, angle of depression, is an angle measured downward from horizon line of reference. That is here. So let's move on to see the example. At one tree farm, a palm tree are harvested once they reach a height of 20 feet. Suppose a farm worker determines that the distance along the ground from his position to base of the palm tree is 22 feet. He then used an instrument called clinometer held at an eye level of 6 feet to measure the angle of elevation to the top of the tree as 30.2 degrees. Is the tree tall enough to harvest? What's the meaning of this? So if the tree, I draw a picture like this. A tree is like this. This is tall, and this is the ground, and here is people, and this is his eyes, big eyes, and he is standing about 22 feet away from the tree. And then we know his height is 6 feet. And I want to measure the height of the tree. So how to do it? Since he told us that the angle of elevation to the top of the tree is 30.2 degrees. That means the degree of the angle of this, the angle of elevation is 30.2 degrees. And we know his height is 6 feet. So I move the 6 feet to here. This is 6 feet. And the tree's height equals 6 feet plus this part. Assume this part is y. So the height of the tree, I use h, equals y plus 6. So how to find the y? So we can see this is a right triangle. And we know this angle. We also know the distance from here to here is 22. Because I can move this length, move it to the top. That's still 22 feet. So that's enough. That's easy to find the y, because we have learned that tangent theta equals opposite the y over adjacent, which is 22. So the theta is 30.2 degree. We use our calculator to find the tangent 30.2 degree, and we isolate the y. So both sides I times 22, so canceled out. Y equals 22 times tangent 30.2 degrees. So this is the y's value. And then go back to this function, h equals 22 times tangent 30.2 degree plus 6 feet, and use your calculator to find the answer. That's I think the front part, this part is 12.8. It's about 12.8. 12.8 plus 6. That's about 18.8 feet. So this one is less than 20 feet because when the tree reach the height of 20 feet, the tree are harvested. But this height is less than 20 feet. So we cannot cut it. It cannot be harvested. Okay, let's move on to see next part. Using trigonometry in aeronautical science. In the example, a pilot on an airplane flying at an altitude of 1 mile. Altitude means the height from here to the ground. That's 1 mile. Size a point at the end of the runway. This is a runway. This is a runway. Because they said side a point at the end of the runway. Where is that point? Is here. The angle of the depression is 3 degrees. So your eye is here, and the depression from the horizon to the downward, that's 3 degrees. What is the distance from D? Distance D from the plane to the point on the runway, run to the nearest tenth of a mile. The D is from here to here. Actually, you see, this is a right triangle. And this one is 3 degrees, and this one is the complement of 3. Use 90. Subtract 3. We got 87 degrees. So in this triangle, we know this acute angle. We also know the height. That means the adjacent of 87 degrees. So we can find the D. So which trig function I must use? That is cosine 87 degree equals adjacent is 1 over the hypotenuse, which is D, because we are looking for D. So I can multiply or take the reciprocal for both sides. So this one go upside down is cosine 87 degree equals 1 over D reciprocal is D over 1, or just the D. So D equals 1 over cosine 87. Use your calculator. We can find it's about 19.1 mile. And remember, round to the nearest tens. Tens is here. Just keep the tens. So that's 19.5. If the question asks you to keep hundreds, That means if I have a number like 19.5474, keep hundreds, keep these two digital. So, sorry, because this is 7 is greater than 5 or greater than or equal to 5. So this one need to be rounded up to 5. So it's 19.55. Okay, let's move on to see another example. The practice, please practice the question by yourself. If you have any question, please let me know. This question example, an airplane traveling at 600 miles per hour at a cruising altitude of 6.5 mile begins its descent. If the angle of descent is 2 degrees from the horizontal, determine the new altitude after 10 minutes. Run to the nearest tenth of a mile. Please pause the video and read the question by yourself. So the airplane is here. Maybe the airplane is look like this. It's flying going to this direction. What do they provide us? So they know the height of the airplane is 6.5 mile. And the degree, the angle here is 2 degree. And the airplane is keep on going to this direction. When the airplane got here, he drive for 10 minutes. He got here, is looking for the latitude, is asking here the distance from this point to the bottom. So we can put h here. Assume the height we are looking for is h, and here is x. So how to find the h? First, we know the distance from here to here is 6.5. And in this triangle, we assume this is x. If we use 6.5, subtract x, we will find h, because this is x, this is 6.5. So the h equals 6.5 subtract x, because this is a rectangle. So h here and h here are the same. So let's see how to find the x, because if we know the x, we can find the h. In this pink right triangle, sorry, in this pink right triangle, we know this is 2 degrees. So the complementary of 2 should be, I assume that theta equals 90 degrees subtract 2 degrees equals 88 degrees. So I just put the triangle here, and I know it's 88 degrees. Okay, so that's all the information they provide us? No, they also told us that traveling at this speed, and after 10 minutes, so we can find this, because the speed times the distance, this distance from here to here equals the speed times t. So the speed is 600 mile per hour, but they tell us it's 10 minutes. 10 minutes equals 1/6 hour. So we have 100 mile. So the distance from here to here he traveled is 100. Right now, we know if we are looking for x, we know this one hypotenuse and the acute angle. We're gonna find the x because cosine 80 degree equals x over hypotenuse, which is 100. So x equals 188. 100 times cosine 88 degrees. So use the calculator. We're gonna find what is that? Let me see. I didn't put my answer there. So just leave the number there and use a calculator to find it. If I know the x, so the h equals 6.5 minus 100 times cosine 88. 88. So we're gonna find the h. That's about 3.01 mile. Some students ask me, can I find my x from this triangle? Yes, of course. You can also use the sine. I mean, if I'm looking for x in this triangle, and I know this is 2 degrees, and we already found that this is 100 miles because it traveled in 10 minutes. And the x here, we can use a sine. So sine 2 degrees equals x over hypotenuse 100. X equals 100 times sine 2 degrees. And if we use h equals 6.5, subtract x, which is 100 times sine 2 degrees, and use a calculator, we will have the same result. Remember, in the result part, round to the nearest tenth of a mile. So this is hundreds. It's about 3.0 mile. Okay, that's all about the chapter 5.2. If you have any question, please let me know. Have a good day.